I'm Pakistani and you watch Mr. Pakistani Tutorial video. I will teach you how you can make a Wi-Fi control car, a Wi-Fi control remote. Suitable. First you can see my part 1 video. I made this star, assemble this star kit. This is the star kit. So that's why in the first part 2 video, I will make a avoidance control task using ultrasonic sensor, and this is a part 3 of this series. We made a task of internet Wi-Fi remote control task. So how I make it? Part 1 I assemble this, so you can see how I assemble this task. Part 2 I connect this motor driver into this task, and part 3 now I will tell you how I made this Wi-Fi control task. So this is based on Node MCU or esp8266 board, which I mount in backboard, and we powered by right now a power battery and power this thing with any other device like a small power bank and rechargeable lithium-ion battery. And this is a motor driver L298N. You can use L293D, but right now I have L298 and motor driver. Both are work same way. First, the motors bias connected to the terminal of the first motor bias connected to the one side of the two terminals of the driver, and second side motor connected second side terminals. And this is that we can use two different power supplies with this motor driver, because this motor driver, sometimes normal motor driver have one in one power supply. So this power supply also need for powering this motor driver and same motor. But this motor driver benefit, you can give separate power supply for motors and one power supply for powering this unit, because this unit module is powered by maximum 5 volt, and this module you have more than 24 motors driving with up to 4 amps of motor drive with this driver. So that's why you can use minimum 5 volts to 48 volts any kind of motor, which motor does maximum 4 amperes you can use with this. So that's why there are one extra pin which is power taking power 5 to 48 volts for providing these two motors. In this case, it's two small motors, it was 5 volts. Then I bridge this 5 volts and this module 5 volts together. So I will instead use two different power supply. I use single power supply for powering both the devices at same time. And there I will ground is always common. Ground goes to the node MCU ground, and this time node MCU is the total voltage is 3.3 volts. Without 3.3 volts, and this is there is one regulator in a node MCU which is known as the AMS 3.3 volt regulator, which regulates the 5 volt USB power into 3.3 volt processor power or main source voltage, which is source voltage used ESP or node MCU used to drive the main processor. And same time there are these modules what directly 5 volt, minimum 5 volt. So that's why I connect this module via in pin and ground pin. So in pin is connected to the USB pin, directly to the USB point. So when I leave in 5 volt, this 5 volt parallelly go with node MCU as well as going to this motor driver, and node MCU steps this 5 volt into 3.3 volt and use for lower voltages. But this module is directly powered by power bank via in pin and ground pin, because in and ground pin is a pin which pin is directly connected to the node MCU. This input female jack. This female jack will get 5 volt. So that's why this single 5 volt goes this module as well as this module same time. Now this module has 4 inputs. Motor driver 4 inputs. So these inputs are 2 inputs for each motor and 2 inputs for other motors. And similarly the 4 outputs, 2 for one motor and 2 for output motor. So input are this time is connected between pin D in my case, pin digital 5, digital 6, digital 7 and digital 8. These are output pins which I outconnect these two pins between these two. These 4 pins system quality is not this connection quality is not a perfect quality. You can one by one connection and then change it, because you may know if you made a local type, I mean normal towers, you need to change a quality, the motor polarity, in order to change the direction of motor. Sometimes motor is forward, one motor is forward, one motor is backward. Okay, you need to change the motor polarity in order to make both motor forward and both motor spin backward at same time. So that's why same fundamental is used same here. You can flip these wires to individual to the other until both motors goes one direction, no matter forward or no matter backward, but it will move only both in same direction. So this two-port connection is all the time changed according to the experiment, because these four signals are not fixed. You can change your according to your requirement. Now I tell a little bit about code. This time you can code. I later explain it by screen share, but right now I explain. Let me open my phone password. First, I installed. This time I increase the brightness. Maybe you can clearly see. So this is a phone. I download first, go to Play Store, like Play Store, Play Store, and I download app, which is app. Let me open it. This I download app. Which app? Let me search this app, and we install this app, esp8266 wifi report. This app is a good app because this app can also provide you static diagram as well as code inside. So you can use this app if code provided code to flash your node MCU, and you can use same way like that. If you open this like that, it will, there are two options, IP and this folder. If you open this folder, and there is a static diagram. With static diagram, if you like this same static diagram, you need to make air in your tower, and it is also provide you some stored in the there, which you can copy it, and you can put either using cell phone, and you can put into transfer into your laptop via WhatsApp and email, and then you can flash to the computer to this node MCU. But when you flashing this code, you need to little bit change it. There is put one line which I little explain in the laptop screen. Right now you can not maybe clear here. There is one line there which is says a Wi-Fi password, which is string STS or string STA password pin. Password, there are 2 points where you put Wi-Fi password and Wi-Fi network. This time you can use your local network like your own network. If you have home internet connection, or you can use a cell phone hotspot driven into this unit in order, and same hotspot you are connected to your cell phone or internet connection is same available in your cell phone in order to control that. Now later explain this code in the end of the video, but there are certain diagram also find. You can use download this ESP Wi-Fi control robot star app made by PCB or PCB company is made by, and you can also everything that in this software this app can provide anything with light code or static diagram. Also this app controls this robot, everything done by this app. Now put this IP, which IP you can, that first time you can power this thing by a laptop, open up serial monitor, the IP address is put here. Your IP address is changed and their username, which username your internet is connected with your device, and then save, and then drive it. This time, if this table is not too much space, I put in the floor and then try at CW and then much faster. Now it's drive test time of the start. Now place it on the floor. Let me place the device. Now let me wait. I open the app. Just wait for a while. Now if I push the go forward, if I move, although it's a little bit slow because due to the power bank is not fully charged. Now you see, come back. Ready. Now I explain stored of this reboot. So you can store file in the software in store provided stored. I provide in the app, which app also give you stored and circuit diagram. You can use that and then you can try this thing. First include Wi-Fi, the esp8266 Wi-Fi touch, because this thing needs Wi-Fi to not using Wi-Fi communication. That's why we can use this library for connecting the Wi-Fi. And then hash include esp8266 web server .h. So we are using this node MCU as a server and my cell phone acts like a client. So I use this command, library, to interface the server with my cell phone as a client. And again, this is include Arduino OTG.h library, int PWM D1, int PWM B D2. These are two. One D2 and D1 is one motor terminal, and int DT DIR A and int DIR B, digital 3, digital 4 are the setting motor 2 wires, and there is a LED and buzzer inside. 2 LEDs, one for Wi-Fi and connection telling information LED, and one is front light LED, and one is beeping buzzer, which I cannot add in my project, but you can, if you like, you can add it. So taunt int PI buzzer pin equals D5, constant int IN int pin int Wi-Fi LED pin equals D0. So DD0, digital 0 pin, is the LED pin, which pin is indicated when internet connection is established or not. And there are string commands, int speed 10 under 23, int speed top 3, control model, which is Wi-Fi, control Wi-Fi remote control model, which is the name of this Wi-Fi, star remote, and serial pin dash for booting, indication of booting. And there are defined pin modes. Pin mode is buzzer pin is output, LED pin is also output, Wi-Fi LED is also output, and by default the LED pin or buzzer pin both are pull down, and Wi-Fi pin is pull I. Set all mode, and there are the pin configurations, which are the pin mode PWM A output, PWM B output, which is, and there is one thing more. If you see there will
all the commands which commands coming from cell phone app, and it will receiving the command and further action it, meaning back for backward, right for rightward, left for left turn, G for forward, forward leftward, GH, backward leftward, I, forward rightward, J, backward rightward, S, stop, and we pinned on W, turn on LED, W, turn on small W, turn off LED, and there is 0 to 8 for speeds minimum. If you press 0, then 330, otherwise 400. If you press 2, 470. If you press 3, it's 540. If you press 4, then 610. And if you press 5, 680. And similar way it will do 1023 maximum speed. And these are the commands sent in by these apps, the app provided app, this Arduino, and Arduino decodes these commands to air, and which use to further what. Now you can see yourself, and this video can be done next to where I can pause.